Good morning and welcome to the Frontiers of Knowledge segment of Dr. Lamba's Awakening Call. A month back, a powerful telescope was sent to the space. And this powerful instrument can detect the heat of a bumblebee, which can be as far away as the moon. Amazing capability to detect to now. Now it has already traveled 1 million miles, almost 1.5 million kilometers, and it has successfully deployed a giant sunshade, mirrors, and other equipment and left thousands of scientists feeling nervous, anxious, and excited. I'm talking about the James Webb Space Telescope. It has reached orbit nearly, as I said, in 30 days, more than 1 million miles. And it slipped into orbit around a point in space last Monday, where it can capture light from the first stars and galaxies. And the purpose would be to see the after effects of the Big Bang. A real historical and path breaking thing is going to happen. For the first time, we are going to see how the first stars and the galaxies were formed after the Big Bang. And as planned, the European Ariane 5 rocket was launched and the Webb was put on a Christmas Day. So 25th of December to 1st of February, it has traveled more than 1 million miles, 1.47 million kilometers. And it's on a trajectory that requires only a slight push to reach the intended orbit. And as a matter of fact, the pull of the sun and the earth interact to form a stable gravitational base. So this is the first time the gravity from the sun and gravity from the space and the earth, these three gravities are going to mingle and the telescope would function. And the push for the telescope came from a 4-minute 57-second thruster firing. Just imagine, 4.5 minute thrust was there, which fired it, and the velocity to begin with was just 3.6 miles per hour. And within seconds, after the first thrust, the second fired, and it was a real marvel of human ingenuity and capable. NASA Administrator Bill Nelson says, "Welcome home, Webb. Congratulations to the team on the hard work because it has reached the safe arrival, one step closer to uncovering the mysteries of the universe." Spacecraft at and near the orbit in the sun in lockstep with Earth, and this would remain on station for the minimum amount of the rocket fuel, allowing a longer operational lifetime than can otherwise be possible. The telescope launch was so precise that there were two subsequent trajectory corrections, that small orbit insertion one, and observers could see enough propellant to exceed the designed life. So the life of it is going to be much more than was originally thought. Really, they thought it would have 10 years life. Now they think it's going to have 20 years life and maybe much more than that. It will also allow Webb to observe the universe while keeping the giant broad side of the sun and the telescope's optics on the cold side. So it's near the sun. It absorbs the sun rays to heat itself, to power itself, but the optics and the instruments, they are not affected. So from Monday, the secondary mirror has cold noon and the temperature near the sun is minus 400 degree Fahrenheit. They think that in the rest of the operational life, the Webb will circle L2 at a distance between 155,000 to 517,000 miles. 100,000 to about 5.2 100,000 miles. And it's assumed that it will take 6 months to complete the orbit. So, if you want to have a layman view, then the way you see is to put your head like a Pringle potato chip. That's what they say. The Lagrange zone gravitational field is a saddle point. So in the middle of the potato chip is a semi-stable point in the solar system. And it's a small trajectory correction thrust firing. The flight controllers are keeping Webb in the sweet spot of the gravitational saddle with a minimal amount of fuel. Now this is something because you are using not the fossil fuel but renewable energy. And look at the precision. 2 near perfect trajectory corrections were done and it was perfectly in time. Each mirror segment is equipped with 7 actuators, 6 of which can make microscopic changes in the orientation. Now you will ask me, what's so big about it? The main thing is that it would get 18 separate images of the stars and the galaxy, align them and then put them one on the other like a stacking. We will be able to see the Ursa Major near the bowl of the Big Dipper, and the 4 instruments will be used to map out where each segment is to be there. So this will define basically the complete process of the creation of the world, right from the Big Bang through the various stages. As I said, 18 different stages. The 18 images would be 18 stages of the process of creation. And then the alignment is a fraction of the width of a human hair. So the width of a human hair is at a nanoscale and its fraction of that. The primary and the secondary mirrors are aligned to optimize the light directed at Webb's 4 science instruments. The first images are expected in the summer and they are having 300 observing programs in the first year. There will be 4 broad science themes. A. How the galaxies evolved from the history of the universe. How the stars and the planets are formed, the process of formation. And not only stars, but then all the planetary systems, both the solar system in which we live and the planets that are orbiting other stars. The cost of this telescope is $10 billion. And next 10 years, they are exploring the depth of the cosmos, sending back baby pictures of the universe from the earliest days. It's like, when you're grown up, you reverse back and start capturing the images right from your toddler days to the teenage, to the youth, to the adolescent, to the adult life. You see, we had a Hubble Space Telescope earlier, and this telescope, James Webb Telescope, is 100 times more powerful than the Hubble one. That was already sending stunning pictures, and that has been happening for the last 30 years. So if it's 100 times more powerful, you can well imagine what adjectives shall you use. If those were the stunning pictures, how would you describe these stunning pictures? Now I'll talk to you today some facts which people are not aware. For example, it is so powerful that it can detect the heat of a bumblebee as far away as the moon. Now, bumblebee is a very small insect. It emits very low heat, and normally you can't detect it, even when it's next to you. But here, this telescope will detect the bumblebee's heat being transmitted by it when it's moving around, even if the distance is as far away as the moon from the earth. It is so sensitive to infrared light, it will be able to detect the slightest heat. Technically, it could see the detail as small as a US penny at a distance of about 25 miles. So you have a penny here, and 25 miles away the telescope would see the complete details of the penny. These activities are not the purpose of the sensitivity. It will allow the astronomers to compare the earliest galaxies to the most recent ones, paint a clear picture of how they were formed, and potentially answer questions about the early universe. Then, the plan is to take the baby pictures of the universe. Hubble was making breathtaking pictures, as I said, but it hasn't allowed the scientists to see the first galaxies that formed after the Big Bang. Now, we will be able to see the story of $14 billion old story of the beginning of the Earth. It is basically designed to see the first galaxies that were formed after the Big Bang. And if it all goes well, it will capture those pictures from the mirror, which are almost 13.5 billion old civilizations or galaxies. So extending our view several hundred miles earlier than the Hubble, back to the time. So it's traveling back. The beauty is you're traveling back to capture the beginning, the origin. And according to the pre-flight testing shows that a final mirror wing holding 3 hexagonal segments rotates into place to fill out the James Webb's Space Telescope. Then it stays cool with a sun shield the size of a tennis court. Since it's going to be near the sun, so they have made a sun shield the size of a tennis court, and this will make it remain cool, not burn up. And that is going to be something which is going to be very useful. The side facing the sun will experience temperature of 260 degree Fahrenheit, but the other side would have minus 370 degree. So nearly a 600 degree difference. Now imagine a tennis court distance, and the difference in temperature is almost 600 degrees difference. Then the mirrors are all covered in gold. It's only a golf ball worth of gold. The golf ball size of the gold has been used. The coating is so thin that a single hair is 1,000 times thicker than the gold coating. So less than 2 ounces of the 24 karat gold reflect infrared light better than the other metals. But don't be fooled. The mirrors are not solid gold. They are made of beryllium. Third, scientists won't be able to fix any issues that arise. That is the problem. It's nearly a million miles away, far away from the reach of the space walking repair crews. So if something happens, they won't be able to repair it. But the way it is, they are thinking of sending a robot to refuel Webb, extending its life. So already they are thinking of 20 years. 10 years was the original one. Now they think it's going to be 20 years. And they are now building a robot which can send a to refuel it, to extend it to much more. And I do look forward to the first pictures which are expected in the month of near the end of April or the beginning of May. That would be a eureka moment for the astronomers, for the geologists, for the students of civilization, history, and mankind. Such developments like James Webb Space Telescope open our eyes to the reality, and all the doubts, all the skepticism about the origin of the earth would automatically be dispelled. While hats off to these makers of this marvelous James Webb Space Telescope.